If it's BYU Idaho, you're not supposed to be lying. Is it going? You've told two lies. One, she says, I didn't do it mathematical. Somebody tell me what about her method was mathematical.
You used numbers.
Used numbers, okay. What else?
Process of elimination.
She essentially used like the scientific method, right?
So she did an experiment and just started Xing, erasing, Xing, erasing, and so on. Right?
That's all mathematics.
And then what did she notice? There was a pattern in the ones that had the odd. That's not mathematical?
It's totally mathematical.
It is totally mathematical. And don't you let anybody tell you it's not. And you better honor your students when they do math that way, because that's math. Now, it's not as maybe high-powered in your own mind as what these other people were explaining, but it's mathematical. Anybody else? Their approach to this problem? Yeah, what did you do?
I got it wrong, but I drew lockers. I drew the lockers because I'm a visual and I like to see it. I think if I would have done more than 10, I probably could have figured it out. But
So the drawing got in the way of how many?
right. Because I drew so many, I didn't have time to draw 1,000. But
Did anybody go into a school with lockers and just start doing it? Right? I mean, you could, couldn't you? What did you do?
Well, first I used like scratch paper, and obviously it didn't look that great. So, and I noticed a pattern like with odd and even factors. So I just did it on graph paper, and then I found that with square numbers they happen to be open. So I just only hit the square numbers and the two numbers around them, so I didn't have to find all of these ones. And I just to double check and make sure that it was only the square numbers, because they have an odd number of factors, which means that they would be.
Did anybody do all 1,000? I mean, did you actually... one of the gals in my class this morning, she took pieces of paper and she did 25 of them. And on one side she put O and the other side she put C. And she had all of them laid out C. Okay? You know, numbers 1 through 25. And then she just went through and actually turned them over as though she simulated it. She didn't go to a school and do lockers, but she did papers. You know, math can be done lots of different ways. And, okay. So, for those of you who didn't solve it, did your discussion with your partner get it solved, or who needs to ask a question about the problem? It boils down to the fact that what? Every person who touches a locker to open or close it, right, to reverse it, the person who does that their number is a factor of that locker number, right? And so the only people that touch a certain locker are the factors of that locker, right? And the only way to get it open at the end is to have an odd number of factors, because that would be an odd number of, I was going to say closures, but odd number of motions, which would leave it open, right? Does that make sense? Okay. Well, we're going to switch gears today, and we're going to talk about divisibility. Divisibility. And before we do anything, we've got to get the rule that we taught you about in your homework that says if A divides B and A divides C, then A divides B plus C. And we might even put A divides B minus C as well. We could put that, I'm going to put that over here in parentheses. That's not where we're going to focus, but what does divides mean? Here's the symbol for divides. What does that mean? Somebody use an example using numbers. I'm saying letters. A divides B. Somebody give me an example.
are you meaning 2 divides 4?
Is that true? 2 divides 4? Yes. Give me another example.
8 divides 16.
8 divides 16. What does that mean when we say divides?
Goes into.
Is a factor of
It's equivalent to saying 8 is a factor of. Is that what you're going to say?
Kind of. I was going to say it evenly distributes it. So like if I have 6 apples and I divide it by 2 people, then I'm evenly giving them each 3.
Okay. And there's no apples left over after everybody has the same amount, right? So there's a remainder of 0. So it's basically saying A is a factor of B, right? So if A is a factor of B and A is a factor of C, then A is a factor of their sum. That's what we're saying. Let's give an example. Give me a number. 5 is a factor of, or divides what?
20.
10. And 5 divides 25. Then what? 5 will divide 35. 10 plus 25, right? The sum? It's true, isn't it? Do you remember the little boxes in your assignments that illustrated that? If I've got a 5 by 2 here, and a 5 by 5 over here, this is a 5 by a 5, and this is 2, and this is 5. If I slide them together to get a 35, right, it's still 5 wide. So 5 is one of the dimensions. All right, this is absolutely critical as we move forward in what we're doing. And what we're going to do is we're going to give you the divisibility shortcuts. Some people call these the divisibility rules. I like to call them the divisibility shortcuts. Okay? Let's start off with one you all know, and you've known you were born knowing probably. No. Real early. How can you tell if a number is divisible by 2?
If it's even.
If it's what?
Even.
If it's even. How do you tell if a number's even? Huh? You just know, right? Come on.
Ends at 2, 4, 6.
It ends. Which end? The left end or the right end?
Yes.
Right end to 1's place.
Okay. The units place. That's the ones place, right? The units place is a 0, 2, 4, 6, or 8, right? You guys already knew that. Okay? What's the rule for 3? We've actually talked about that a little bit in here.
The sum of the numbers.
The sum of the digits is divisible by 3. Okay? So, let's see. Let's pick a number here. I'll just make one up. 8, 1, 2, 7, 5, 9, 4, 6, 1. Let's go 5, 3. Let's see. That's 81,275,946,153. Is it divisible by 3 or not? Well, we could divide it by 3, right? But I think this is a bit of a shortcut. Let's just try it. Let's add the digits. 8 plus 1 is 9, 11, 18, 23, 32, 36, 42, 43, 48, 51. The sum is 51. Is it divisible by 3?
Yes, it is.
If you're not sure, add the 5 and the 1. What's it? 6. 6 is divisible by 3. Therefore, 51 is divisible by 3. And if 51 is divisible by 3, according to our rule, this is divisible by 3. Go ahead, take your calculator and check it out. Or divide it out longhand if you'd like.
2 hours later.
That's not
Do you see why it's a shortcut?
Yes.
Now let me show you why that works. You're going to need to come over here and sit and face this one up here. Okay. This works because of the divisibility of a sum rule that we just went over. Okay. I need you to follow along, and you probably want to take some notes here with this. If I start with a number A, B, C, D, and you say a number, well, we're going to prove it for any 4-digit number, and then you can see how we could expand this to any number of digits. And the digits can be anything. So help me, if this is my number, can somebody give me the expanded notation for that number?
This is just a guess. Is it A0, 0, 0 plus B, 0, 0 plus C, 0?
You're on the right track here. Why did you say that?
Because A is actually A 1,000.
It's in the thousands place. So if I wrote it as 1,000 times A plus what?
100.
100 times B plus 10 times C plus D. That's what I was after. And
Okay.
yeah, so this would be A 1,000.
Yeah.
Everybody agree that that is the value of this number? You with me? Okay, see if... Don't let me make any mistakes. If this is true, then this is true, and if this is true, then that's true, right?
Yeah.
You agree with me? Why? Because 1 plus 999 is 1,000, 1 plus 99 is 100, and 1 plus 9 is 10, right? I can write it that way if I want. All right, let's see what we're going to do here now. Everybody know what I've done now?
Yes.
Distributed.
I distributed, right? Cross the parentheses. You guys remember this from algebra? So this is the same as this too, because they're all the same as each other. All right? Now what I'm going to do is this. See if it's legal. Is that true?
Yes.
What did I do now? I rearranged it. Somebody know the name of the property? Commutative. Hey, pulled it out of that gray matter and says, commutative property says when we're adding, the order does not matter. 2 plus 3 is the same as 3 plus 2, right? So this is the same as this. Now, I'm going to do this. Now somebody tell me what I did. Is it still true?
Yes.
Yeah.
I can drop the ones, right? Because 1 times anything is itself, right? 1 is the multiplicative identity. It does nothing when you multiply. So I can drop it. What happened over here?
Pull out it.
I factored out, I used the distributive property in reverse, factored a 3 out of each of these coefficients. It's right here. Here's what's left, right? If I were to distribute this back, I would get back to here, right? We okay then? We're still... All right. Now, what I want you to look at is if A divides B and A divides C, then A divides the sum of B and C. So, what I'm going to look at over here is I'm going to say, here I've got, this is my B and this is my C. And I know that 3 divides, this right here is C. I know that 3 divides C. How do I know that?
Because you can divide that by 3.
Because it says 3 times this gives me the number. Right? If 3 times something gives me a number, guess what? That number is divisible by 3. Right? Because it makes it a multiple of 3. Everybody follow that? I know for a fact that this number in the square is divisible by 3 because of that. So, guess what? C is divisible by 3. Now I've got to find out if B is divisible by 3. So I come over here, here's my B. If I can find out if this is divisible by 3, then guess what? The sum, which is this, will be divisible by 3. Does that make sense? So guess what I do? I add up the digits, and if they're divisible by 3, I already know this one's divisible by 3, and if this one is, then that one will be 2. You with me? I'm seeing some nods. Who wants to ask a question?
Is it similar to the homework where you had to divide it and see if it, like, some of the questions? Where you do kind of the 100A and then...
I'm not sure which part you're talking about in the homework. Last night's?
I think it was, yeah, I think it was last night's. Where...
The adding and subtracting.
Yeah, the adding of subtracting with prime factorization.
We had you doing some of this stuff, getting ready for this.
Oh, okay, never mind.
Anybody else want to ask a question? I'm not quite sure how to answer your...
Yeah.
So over here, it just A, B, C, and D represent
The sum of the digits.
Okay.
And this represents the rest of the number, but we know 3 divides it, so all we're worried about is, does 3 divide the sum of the digits? If the answer is yes, then it goes into the number. That's why we can take this number and do that.
Okay.
Okay? Do you follow it? Now, the question I want to ask is, or the thing I want to point out is, you really don't have to get this sum to be able to tell if this is divisible by 3. Let me just show you what I mean. I'm going to come through here, and anything that's divisible by 3, that one, and that one I'm going to cross out. Those numbers are divisible by 3, so guess what? Their sum is divisible by 3 as well, right? Then, if I put 5 and 1 together, I get 6, and it's divisible by 3. Let's put 5 and 4 together. They're divisible by 3. Look at this, how this is going nice. 2 and 7 is 9. It's divisible by 3. So is 8 and 1. So guess what? Every number or pair of numbers that I've connected is divisible by 3. And there's none left over, so guess what? It's divisible by 3, and I don't even know what the sum is. I do. It's 51 because we already got it. But I wouldn't have to. Does everybody follow that? That's an even shorter cut than this one. Okay? 4. What's the divisibility rule for 4? Or the, not rule, shortcut. Anybody know? Ends in a 4. 24, yeah, it's divisible by 4. Does that work? So is 12, and it doesn't end in 4, so that's not it. Come on.
And 14 is not divisible.
14 isn't either, so it's not ending in a 4, right? What is it? Nobody's learned this one? This is a handy one. The number formed by the two rightmost digits is divisible by 4. So let's take our number we've got up here on the board. What is the number formed by the two rightmost digits? 53. Is the number 53 divisible by 4? No, because it's not even, right? And it's at least got to be even, but not all even numbers are divisible by 4, so we don't even have to worry about it. This entire number here is not divisible by 4. Why does this one work? Here's why it worked. Yeah.
I was just going to explain that real quick.
Do. Go ahead.
Well, because 4 goes into 100, and since the last two digits aren't in the hundreds place, but the next one is, then it goes into that automatically, and then when 100 goes into the next one, then it keeps going, like 100 keeps going into it.
So people are nodding. They're catching on.
Does that make sense? Yeah, so 4 goes into 100, and since that's the hundreds place, you don't have to worry about anything before that.
Oh, okay. Yeah, I get that.
Does everybody agree that this number is the same as this?
Yes.
Right? And what she's saying that 4 goes into 100, right? 4 quarters, right? In a dollar? I mean, we just kind of were born with that too, right? So if 4 goes into 100, it must go into 6100, and it must go into 46100, and whatever other 100, so I don't have to worry about this part. All I've got to check is the number formed by the two rightmost digits. Does that make sense? So what you say is exactly right, but what you may not have realized is that it comes from this right here. If 4 divides this, and it does, all I've got to do is check to see if 4 divides this, and if it does, then I'm good to go.
So like how would that work with the number 12?
The number 12, the last two digits on number 12 is 12.
But like, oh, so you were like
So as long as I have 12, I could put a 5 here, I could put a 7 here, I could put an 8, I could put anything I want here. I don't care. 4 is going to go into it.
it's not like that, the 1 and the 2, you would add them.
No, you don't add them. That's why I didn't say the sum. I said the number formed by. Okay? Okay. Good. I'm glad you brought that up because that's a difference. And you don't want to add them when you're supposed to be using the number. Okay? 5. You guys all know the rule for 5, right?
Ends in 0 or 5.
You learned this in about 1st or 2nd grade because you counted by 5s, right? And they all what?
0 or 5.
The units digit is 0 or 5. It actually works this same way here. Look, if I were to do this, 8, 1, 2, 7, 5, 9, 4, 6, 1, 5, 0 plus 3, that's this number up here, right? Well, we know this number is divisible by 5 because it ends in a 0. All I've got to check is the ones place. Is it a 5 or a 0?
No.
And you can do that with the units place too. We know this one ends in 0, so this whole thing is divisible by 2. All I've got to do is check this one. Is it divisible by 2? See, it's this. They all come back to this. All of them. 6. Anybody know the rule for 6? The shortcut for 6. Try it.
The sum of the digits is divisible by 6.
What do you think? Sum of the digits divisible by 6. 36 is divisible by 6, but the sum of the digits is 9. The sum of the digits is not divisible by 6, but it's still divisible. That must not be it. Did you follow? Huh?
By 3.
It's divisible by 3. Yeah.
But that's the same rule as 3.
So if it's divisible by 3, that means would this number be divisible by 6 then? Because it's divisible by 3. We proved it. So is this one divisible by 6?
No, well,
You
39 is also divisible by 6, or by 3, but it's not divisible by 6.
39. 3 plus 9 is 12. That's divisible by... But this isn't divisible by 6.
Right.
Yeah.
What if it's the same as 3, that the sum of the digits is divisible by?
He's just looked at
This one is, the sum of the digits is divisible by 3, 51. So you're telling me this number is divisible by 6?
We're saying that's not necessarily true because then 39 would be divisible. If you said that, 39 would be divisible by 6, but it's not.
But it's not.
If it's divisible by 6, then the 3 would have to go into the number an even number of times.
Yeah, there might be a leftover, a remainder of 3.
Yeah.
If it goes in like 6.
This one, everybody knows this one's not divisible by 6, right?
Yeah.
What?
The reason that doesn't work is because it's only gonna, if you were to go down a number line, that would only work for every other number.
Oh, do you know what she's talking about?
Like if you look at your sieve, it would show all the 3s all the way down, and it's only every other one. It's only
Every other one of those.
So it works for 9.
So what are we gonna, how are we gonna tell with 6? Check the rule for 3 and
Add.
2. So check it for 3. If it's yes, it's divisible by 3, then you check it for 2. If you get another yes, guess what? It's divisible by 6.
So all the even numbers that are divisible by 3.
Ah, that would be another way to say it. All the even numbers that are divisible by 3 would be divisible by 6. And think about that. 6 is made up with what? 2 prime factors? 2 and 3. So it's got to be even, because 2 times 3 gives you an even number. 2 times anything. It's got to be even. Does that make sense? 7. 7.
Is it 3 and 4 or no?
There are several divisibility rules for 7, but none of them are very good divisibility shortcuts. And this is a class, I think, about shortcuts. So I'm going to show you what I think is the shortest way to tell whether a number is divisible by 7 or not. Are you ready? I'm going to divide this number by 7. I'm going to divide the entire number by 7. Tell me what you think about this method. This is called short division. 7 goes in here once with a remainder of 1. 7 goes into 11 once with a remainder of 4. 42 have a remainder of 0. Goes into 7 once, remainder is 0. 7 goes into 0 times with a remainder of 5. 7 goes into 59, the remainder of 3. 7 goes into 34 with a remainder of 6. 7 goes into 66 with a remainder of 3. Into 31 with a remainder of 3. Into 35 it goes. 35, the remainder nothing. Goes into 3. There's a remainder of 3. So if there's a remainder of 3, guess what? This whole number is not divisible by... That's not very slow. Why do you think we call it short division? Because it took me a shorter amount of time. And you didn't see any numbers written down underneath where I went, 7 goes into here one time, times it, put 7 and subtract, and put the 1 here. No, I put that 1 right up here. I'm just carrying those. So it's short this way too, right? This thing would have been clear down to the floor by the time we got done. Right? You with me? Did everybody see what I did? Do I need to do it again?
Sorry, I just have a question. So then you went to 1.
So 7 goes into 11. Notice I wasn't writing the quotient. Why did I not care about the quotient? What did I care about?
looking for if there's a remainder.
If the remainder 0, 7 is a factor of this number. If I get something other than 0, then it's not. That's all I cared about. So I was just writing the remainders, not worrying about the quotient. Do I need to do...
So why would it be remainder 3?
Why would it? Because I got right to here and it went into 35 5 times with no remainder, so I put a 0 there. Then 7 won't go into 3. So I would put a 0 up above here, and then there would be a remainder of 3, and that means it's not a factor because I need a remainder of 0 for it to go in with.
What did you do when 7 went into 5?
Remainder of 5.
7 won't go into 5. It goes into 5 0 times. So what's the remainder? 5. Right?
Didn't take anything away because 7 didn't go in.
Let's just do it. 7 goes into here once, right? 1 times 7 is 7. I subtract, get 1. That's my remainder. 7 goes into there once. The remainder is 4. 7 goes into 42 6 times. There's no remainder because it went in evenly. 7 goes into 7 one time, no remainder. 7 goes into 5 0 times. 0 times 7 is 0. Subtract, you get a remainder of 5. 56, right? You see how it works? Okay. Here's what I'd like you to do. Question first.
You can use any number when you're doing that, right?
Yes. It's just, see, let's get a great big number. You divide that way with 3. I'll use the shortcut for 3. I think I can beat you. Even if you practice this and get really good at it. Here's what I'd like you to do. I'd like you to go home and Google divisibility rule. Don't put shortcut, because they're not shortcuts. Divisibility rule for 7. There's more than one, and they're really cool. They're way cool. Try them, practice them a bit. Come back. We'll put a great big number on the board. You'll have your back turned, and I'll have my back turned. Somebody will write a great big number on the board, and then you'll say go. I'll do my short division. You'll do your trick you learned on Google. We'll see who can win. I don't think they're shortcuts, but they're way cool. And see if you can find out how they fit this divisibility of a sum thing. Okay? Yes?
Is doing that way, will that help you find the answer, like, even with the remainder? Like that number divided by 7?
If I'm I wasn't writing these or worrying about them, all I cared about was the remainder. What was your question?
Yeah, but if you fully wrote those, is that...
If I fully wrote those, I have the answer to the division problem with the remainder included. Yeah.
I like that one.
Whenever you're dividing by a one-digit number, short division is a really good option. Takes up less paper, takes up less time. Yes?
So at what point in time would you decide to teach these shortcuts to a student? What age group or what would they be?
That's a really good question. Would you bring that up after you've done the homework this weekend?
Yeah.
We'll talk about it in class, because I think you need some experience with this to be able to talk about it a little better, and I need some time to get the other divisibility shortcuts out to you. Okay, so 7, short division is my recommendation for the shortcut. Not for a rule. There's some good rules out there. Go learn them. They're fun. 8. Anybody know the rule for 8? Yeah. Excellent. So, 12. Does 2 and 4 work? But 8 doesn't. So 2 and 4 isn't going to be the shortcut. Great idea, though. That's the kind of thinking we want to be
Why
doing.
does it work for 6 and not 8, though?
Why does it work for 2 and 3 for 6 and not 2 and 4 for 8?
Oh, wait, because it's time backwards.
4 isn't a prime number.
Good question. You what?
Isn't it because 4 isn't a prime factor of 8? The only prime factor of 8 is 2.
Yeah, but if I wanted to do 24, I could use the rule for 3 and the rule for 8. And if it was true for those, it would be true of 24. And 8's not prime. But we don't know the rule for 8 yet. Come on, help me.
Who else is that?
Here it is. The number formed by the 3 rightmost digits is divisible by 8. So I look at this and say, is 153 divisible by 8? Yes? No?
No.
Then this entire number is, and I don't have to worry about any of the rest of this. Why does this work?
Because it can go into the thousands.
Because 8 will go into 1,000 an even number of times with no remainder. Right? Do you agree with me?
Yeah.
8 goes into 1,000. How do I know? How many times?
125.
125. How did you know that? Did you divide it?
Yeah.
Actually, this is what you should have done. You should have broken the 1,000 down into 10 times 100, right? And this into 2 times 5. And this into 10 times 10. And this into 2 times 5. And this into 2 times 5. And you get 2 times 2 times 2. That's 2 to the third times 5 to the third, which is very sensible because this is 10 to the third, right? And so 10 is just 2 and 5, so that should just be this, right? Well, where does my 8 come from? All the 2's, and the other partner is all of the 5's. So if 8 will go into 1,000 125 times, how many times will 8 go into 2,000? 250 times. How many into 3,000? 375 times. How many into 4,000? 5,000 or 500 times, right? So if I wrote this 8, 1, 2, 7, 5, 9, 4, 6, 0, 0, 0 plus 1, 5, 3, I know 8 will go into this because it goes into every 1,000. So all I have to worry about is the rightmost 3 digits. With that, I think you can do the homework. But you need to put your thinking caps on, because some of the ones I'm going to be asking you about are related to some of the ones that we have done, and you need to be able to make that leap. You'll be okay. Stop it.